So we're going to practice some more of these tricky exponential kind of problems here. So in the first one, we have using our properties of exponents, when you divide, well, first let's back up. Let's write all of these powers, the 2, the 8, and the 16 as powers of 2. So 2 to the x squared stays the same, but 8 is 2 to the third, and when we raise that to the x power, and you raise a power to a power, we multiply those exponents. And likewise, 16 can be written as 2 to the fourth. Now, the property of exponents, it says when you divide two powers of the same base, you can subtract those exponents. So it becomes 2 to the x squared minus 3x equals 2 to the fourth. So now, finally, when we have two powers with the same base equal to each other, we can set their exponents equal to each other. So that means that x squared minus 3x must equal 4. To solve a quadratic, we want to make it equal to 0. So we'll subtract that 4 to the other side. We'll do our box and diamond, or however we're going to factor this, and that will become an x minus 4 times an x plus, I think, 1, and that means x can be either 4 or negative 1, and those will both work for powers. Now, looking at the next one, using that same strategy, we're going to leave the 3 to the x squared. The 9 we're going to recognize as 3 squared. Raised to the x will make that 3 to the 2x. And then we will have 3 to the third is the same thing as 27. Subtracting the exponents will make this 3 to the x squared minus 2x is equal to 3 to the third. If two powers of the same base are equal to each other, that means their exponents must equal each other. To solve a quadratic, we'll make it equal to 0. We'll do our factoring and get that x can be both 3 and negative 1. Okay, next one, you can do this either order. I'm going to just multiply the first two together and add exponents. 9 plus negative 2 is 7. And then we can use our property of exponents that we subtract. So we'll get 7 minus negative 5. So that's going to make that be m to the 12th. Now here, I'm going to not be in a hurry to raise these to the power, to the 7s, because I don't really want to take 7 to the third. But we can think of that as 7 to the negative 3. And then when we multiply these exponents, that's going to be m to the negative 9. We're going to get a 7 to the second, and then an n to the 8th. Now, when we multiply these, the 7s hit each other, and we get 7, add the exponents, is negative 1. We'll get, I think that was supposed to be an n right there. These have to be the same base. So that's going to be n to the negative 1 when we add those exponents. So we can either write that as 1/7 n to the negative 1, or we could move both of those into the denominator and call it 1/7 to the n. Either one's okay. Here you must resist trying to distribute an exponent because it does not distribute over addition or subtraction. Instead, we will think of this as 1/7 minus 1/7 squared is 49. We'll get a common denominator so that we can subtract these fractions. That will be 7/49 minus 1/49, still holding off on the negative 1 exponent. 7/49 minus 1/49 is 6/49. Now that we have a single fraction, that negative 1 exponent will make it the reciprocal. And you're welcome to leave it as 49/6, or I guess since 7 times 6 is 42, that would, or I guess we want to go rather 6 times 8 is 48, so we could call that 8 1/6 if we wanted, but either one's okay. Here is really tempting to start moving 2's all over the place, but that's not okay with that plus sign. So instead, we're going to call this 1/2. We're going to call this 1/2 plus 1 over 2 squared is 1/4. We'll get common denominators here and multiply top and bottom there by 2. So that's going to be 1/2 over, that's going to become 2/4 plus 1/4. So being patient here, leaving that 1/2, 2/4 plus 1/4 is 3/4. Now we have division of fractions, so that's going to be the 1/2 in the numerator. We'll multiply by the reciprocal and call that 4/3. Whoops, there's my left hand coming in the way, and we can cancel and go top times top and bottom times bottom to get 2/3. Let's see what we got next here. So here we can distribute this whole 3n to the negative 1/5. The coefficient 3 multiplies the coefficient 1 to become 3. We'll add those exponents. That will become 10/5. But of course, 10/5 is just 2. On the next one, we'll get 3 times negative 2 is negative 6. We'll add those exponents. That's supposed to be a 6/5, making that 5/5, which is just n to the first. And those are not like terms, so we'll stop there. Here we'll take, now these are being multiplied raised to that power, so we'll take 32 to the negative 3/5. We will multiply these exponents, and the negative 15 times a negative 3/5, we can cancel the 5, and so that's going to be a negative times a negative is a positive, and then we'll get n to the positive 9. Now the 32 is 2 to the 5th to the negative 3/5, and we can again cancel those exponents, or those fractions rather, and so that's going to become 2 to the negative 3, which is 1 over 2 to the 3rd, which is 1/8 n to the 9th. On the next one, we'll use our properties of exponents in the numerator. When you multiply those two powers, we'll add their exponents. N plus n is 2n. 1 plus 2 is 3. In the denominator, raising a power to a power, we multiply those exponents. When we then divide those powers, we'll subtract the exponents, which will leave us with b to the 3rd. On the next one, we're going to first find a linear function. So that means we want the slope. So we can go 14 minus the 3 over 5 minus 2 is going to be 11/3. That's our slope. We can take either of those points, and we can just make our life easy and get a point slope form. So that would be y minus 3 equals 11/3 times x minus 2, and we're good to go. If you really want to write it in functional notation or get the y by itself, you could then, let me move that down a little bit, you could add that 3 to the other side, and you can always do more, but I would be totally okay with that. Now the next one gets a little more challenging here. So we're thinking of something in the form y equals ab to the x. So we can say 3 is equal to ab to the 2nd. We can also say 14 is equal to ab to the 5th. I'm going to put the smaller one underneath, and then if we divide those, then we'll get 14/3. The a's will divide out. That's the nice thing about this. we'll use our properties of exponents. B to the fifth divided by b to the second is going to be b to the third. We'll need to get b by itself, so we're going to take this 14 thirds and raise it to the 1/3 power. And I'm going to put that on my calculator and then write it down to 3 decimal places, but I'm going to save all the decimal places of accuracy on my calculator. When I do that, I'm getting 1.671. So now we have y is equal to a, and our b is going to be, I'm going to write it down rounded, but I'm not going to do computations with the rounded number. So now we want to find the a, so I'm going to use this one right here. So we have 3 is equal to a times 1.671 to the second. And so that means that a is going to be 3 divided by 1.671 to the second. And so I'm going to go 3 divided by, I'm going to go up arrow and capture that 1.671099312, and then square that, and then hit enter on my calculator. So the a, and I'm going to round now to 3 decimal places, I'm getting 1.074. So that makes our equation 1.074 times the 1.671 to the x power. Okay, let's on the next screen. So we're going to graph these here. So on this one, we can see, I'm going to do this in stages here. So the 5 to the x is going to be our basic exponential growth function. So it's going to look like this. So there's y equals 5 to the x. Now the negative part is going to reflect this in the x, so now it's going to look something like that. There's our negative 5 to the x power. Now the 3 is going to multiply every y value by 3. In particular, this one that was at -1 is now going to be at 0, -3. And these really small y values are going to get multiplied by 3, and then the bigger ones are going to get multiplied by 3, and so it's going to kind of grow apart there. So these, you can't slide the blue rather, on top of the green and get a perfect fit, because they're no longer congruent, you would say, in geometry. Okay, and our asymptote has not changed, so that asymptote is still going to be y equals 0. Let's see what happens on the next one. So our 4 to the x is going to be our basic exponential growth function. So there's 4 to the x. Multiplying by the 1/3 is going to multiply every y value by 1/3. In particular, this one that was at 0, 1 is now going to be at 0, 1/3. Every y value is going to be 1/3 the height that it was before, and so it's going to kind of flatten that curve a little bit, but it does not change the horizontal asymptote, which remains y equals 0. Very good.